Hello everyone. So I'm making a video after a while. So today we will be solving a problem called rotting oranges. So before beginning and getting to this problem, let me tell you one thing that this problem is one of the most asked problem by Amazon in their interviews. So this is a very important problem to know. And if you are preparing for the coding interview, this is one of the must known problems. So let's see what the problem statement says. In a given grid, each cell can have one of three values: value 0, value 1, or value 2. So what this value 0 means? Value 0 means empty cell, and value 1 means it has a fresh orange, and value 2 means it has a rotten orange. So here in this example we can see given 2 1 1 1 1 0 and 0 1 1. So here we can see this 2 signifies rotten orange, which is indicated by a cross, and these ones are fresh oranges and these zeros are there are no oranges over here, so these are empty spots, so that's why 0. So okay, so what we have to do is every minute any fresh orange that is adjacent four directionally means what? For this orange, four directions is upwards, downwards, left and right. So for every orange four directionally to a rotten orange becomes rotten. So which basically means that if there is a rotten orange and it has within its four direction any of the fresh oranges, then it will infect or rather rot that fresh orange, and that corresponding fresh orange will be rotten because it's in direct contact with this rotten orange. So now we have to return what? Minimum number of minutes that must be elapsed until no cell has a fresh orange. So that means what? We have to make this whole grid of oranges as rotten orange. And if it's not possible, then we have to return -1. And if it's possible, we have to return how many minutes we took. So here in this picture we can see that first this orange is rotten. So after first minute it infects these two oranges, this one and this one. So after first iteration these two oranges are infected. So after second minute this orange infects these two oranges, and after third minute this orange infects this orange, and at the last this one infects this one. So it took total 1 2 3 total 5 minutes because it's starting from 0, so the answer is 4. So it took total 4 minutes for each orange to get rotten. So let's look into the second case where the answer is -1. So here the grid is given like 2 1 1 0 1 1 1 0 1. So here we can see this one at the left corner is separated by two of the blank spaces. Let's say in this picture here we had one orange and there were two empty spaces over here and over here. So if the rotten orange is somewhere like here, it cannot infect diagonally, right? So that's why after the end of the whole process this one will remain fresh. So that's why we have to print -1. If at the end of the process if any one of the oranges is remaining fresh, then we have to print -1. So by looking at this we can clearly see that this is looking sort of like a breadth first traversal. Here we are going breadth first over this grid, so we have to apply BFS over this grid to find out our solution. So let's see how we can apply BFS over here. So as I told, we will be doing a BFS over this grid. So let's start coding the BFS solution. First of all, before starting the BFS, we have to store the current state of the board. So what the current state of the board actually means is we have to know how many fresh oranges are there in the initial stage and how many rotten oranges and their locations or positions. So for that we will be using one queue because we are using BFS, so we have to use one queue. So first we will have a variable called fresh and one rotten. So this fresh variable will be counting the number of fresh oranges in the grid initially, and this rotten will be a queue which will store the current positions of the rotten oranges. So now let me just store the row and the column values of the grid. So row is len of grid and the column is len of grid of 0. Column is len of grid of 0. Okay, so these two are the rows and columns. So now we will start traversing the whole grid using a loop for r in range row, for c in range column. So first we will check if the element in grid of RC is equal to 1. That means it's a fresh orange. So we have to increment the fresh counter. Fresh counter is incremented by 1. So we have incremented the fresh counter. Now we have to check else if the grid element is already rotten. So that means what? If an orange is rotten, the value of it is 2. So then we will append or rather enqueue that location or its uh, position to the queue, which is named as rotten. So rotten dot insert 0, as we are using a queue, so it's first in first out, so we will be inserting at the 0th index, and we'll be inserting a tuple of the current position of r comma c. So after these two loops we successfully stored the initial condition of the grid, where the fresh oranges are, where the rotten oranges are, and how many fresh oranges are there. So after that we have to initialize one variable called, let's say, minutes is equal to 0, and at the end we have to return this variable minutes. Okay, so in between we are going to implement our BFS logic. So for BFS, as it is seen in this problem, that we have to go 4 directionally. Okay, so let us just make an array of these 4 directions. So what these 4 directions could be? So it could be 1 0 or 0 1 or -1 0 or 0 -1. So what this 1 0 0 1 means? So 1 0 means one step to the right, 0 1 means one step to the upwards, this means one step left, this means one step down. So these are the 4 moves which are allowed. So as any standard BFS, we will first check, we will first run a loop until the queue is not empty. So while len of rotten. So inside this while loop, we will first do what? For each element of the queue, we will first pop it and we will check its 4 directions, and if any of the direction is fresh orange, we will make it rotten, and that rotten element we will again enqueue to the existing queue. So this is the whole structure of the problem. So now we will loop through each and every element in the queue which are existing right now. So for underscore in range len of rotten. So this loop will run for each and every element in the rotten queue. So now we will pop the current index, current x, and let's say current y of the current rotten element. So let's say first we have stored 0 0, so we will pop, so current x will be 0 and current y will be 0. So we have successfully popped that. So now what we will do is we will check with respect to this element its 4 direction, this direction, right, left, and so on. So we will check now its 4 direction if there are any fresh oranges or not. So for doing that we have to use this move array. So for this move array, let's name this index as capital X and capital Y in move. So we have to add the current x and current y to x and y, because we are going right, left and up and down. So current x, current y. So these are basically, this x and this y are basically the four neighbors of this current cell, the four neighbors. Okay, so after that we got these two positions. So now we have to check if we are going outside bound or not. So for checking that purpose, we will do an if condition like this. If the current x is less than our rho and greater than equal to 0, and same as x, we have to check y also. If y is greater than equal to 0 and less than column or not. So these two conditions are basically meaning we are staying inside the grid, we are not going outside, because for this example over 0 0, if you -1 and go left, it is going outside the grid, so this can't be happening. So if we are inside the grid and the corresponding or the neighboring element or neighboring orange is a fresh orange, then only we will make it rotting. So we will also have to check that. So grid of x and y is equal to 1. Only if these three conditions are satisfied, then only we will make what? Grid of x and grid of y is 2. That means we made this as rotten orange. Okay, so now after doing this, we will also decrement the fresh counter, because one fresh orange is rotten by the current by this current x and current y positions rotten orange. So one orange get infected, so the fresh counter gets decremented. So now the new location of the rotten orange has to be inserted in our queue. So for that we will do what? Rotten dot insert 0 comma again a tuple x and y. So this means what? We have inserted or marked the current rotten element inside our rotten queue. So after that, for each step we will increment the counter, which is minutes. We will increment this counter called minutes for each iteration of this BFS. For this is a total iteration for every element in the queue. Again, once this one is done, again we will do for this one, then all its corresponding elements will be infected. Then for this one, all its corresponding will be infected. So we are doing like this. So that's why we are incrementing minutes over here. So now at the end, if we only return minutes and we will run, we will see something like, okay, so we see the answer is coming out as 5. And why is that? Because as I already mentioned that we are starting with 0th minute. So we have to -1 the answer always. So that's why the answer will come as 4. Okay, so now if I do one thing, you will understand it better. Like if I run this second example, you will see we will encounter one error. And what is that error? Here expected is -1, but we are getting 4. And why is that? As I mentioned, in this example, this last element will be remain fresh, and if any one of the oranges is remaining fresh, we will print -1. So we are not checking that part over here. So we will do one if condition check. If the fresh counter is still remaining greater than 0, then we will return -1. So now if we run it, we will see it's getting correct answer. So now if we submit it, we will see there is still one problem. So first I have to submit it and then tell what is that problem. So let's submit it. So we see this one is getting wrong answer, and if we check the details, we have passed all the test cases, 302 of 303, just one is remaining. And why is that? Let's just understand that. So here the input is given is 0, so that means what? There is only one cell and that cell is also empty. So it means what? There aren't any oranges. So that's why the expected output is 0. So that means if we have to rotten some oranges, there has to be first of all some oranges be there, right? So there aren't any oranges, so how can we rotten that oranges? So for this example specifically, we have to do what? We have to put one condition over here. If just in case for this specific input the output is -1, we will take the maximum of 0 or the output we are getting minutes -1. So now if we submit it, we will see it will get accepted. So yeah, it is getting accepted. So let's just look into the details, and let me just run you through the time and space complexity of this algorithm. So as we are doing standard BFS, so we know the standard BFS algorithm is linear time, so it will be obviously order of n, and the auxiliary space used over here is a q, so the auxiliary space complexity is also order of n. So this is how we solve this problem called rotten oranges using BFS. So thank you for watching. Hope this video will help you in your interview preparation, and do like and subscribe if you liked it.